Okay, today we're going to be looking at our last family of functions. So far we've done linear, exponential, quadratic, and absolute value. This last lesson is going to be about the square root function. So in this do now, we're going to start by just reviewing some basics about square roots. Remember that for square roots, what you want to ask yourself is what number times itself gives me that number that goes here. So if we start first with the square root of 9, we know that the square root of 9 is 3, because 3 times 3 is 9. We know that the square root of 4 is 2, because 2 times 2 is 4. And we know that the square root of 0 is 0, because 0 times 0 is 0. However, when we get to these negative numbers, if we try to come up with the square root of negative 9 or the square root of negative 4, nothing is going to work. We would just get an error. These are imaginary numbers, which you would learn about in high school, but for now, we'll just know that this is an error. There is no square root of a negative number. So let's take a look at what the graph looks like. When you want to graph the square root of x, you would type in y equals. If you notice on the bottom of your keyboard next to the A, B, C button and the pi button, there is the square root symbol. If you type that in, it will give you the radical symbol, and you could type in x for the square root of x. So taking a look at what that graph looks like, you'll notice that none of the graph exists over here on the negative side. Like we just said, you can't take the square root of a negative number. So the first point that we see here is at 0, 0, and then you see that the graph gradually grows over to the right side here. So this confirms what we saw in our do now here for the square root. So now that we have a general idea what the graph looks like, we're going to take a look at how to transform that graph. You're going to want to be in your packet Function Families Part 2, starting on page 5. When we're talking about square root functions, our parent function that we always want to focus on is y equals the square root of x. That's our original function. But if we're looking to make some transformations, we're going to look at y equals a times the square root of x minus h, and then plus or minus k. So hopefully this is starting to look familiar to you by now. We've been using a, h, and k, and you'll see how they transform the square root function is very similar to the other functions. In activity A here, we're going to look at transforming our k value on the end. So let's see what happens when we put a plus 2 on the end or a minus 1 on the end. So taking a look here, you see the original parent graph, f of x, is right here in the middle. Like we said, it starts at 0, 0, and it gradually grows from there. If we look at the g of x function, that's this graph up top here, so we notice that by putting this plus 2, instead of our graph starting at 0, 0, it now starts at 0, 2. So the effect that this plus 2 has on the end is that it moves our graph up 2 units. Looking at the h of x function, that's this graph down here, by putting this minus 1 on the end, we notice that now our starting point has changed from 0, 0 to 0, negative 1, which means that the graph has been moved down 1 unit. So just as with all of our other parent functions, we know that adding a value of k on the end moves the graph up, subtracting a value of k moves the graph down. Let's take a look at activity B. For activity B, we're going to be seeing what happens when we change our h value, or a number inside of that square root symbol, underneath that square root symbol. Let's see what these graphs look like. If we take a look, again, we start with our original f of x function, which is right here in the middle. So looking first at g of x, that's this one over here that's been moved to the left. You'll notice that instead of starting at 0, 0, it now starts at negative 2, 0. So the entire graph has been shifted to the left 2 units. Looking at our h of x function, that's this graph over here to the right, no longer were we starting at 0, 0. Now our starting point was at 1, 0, meaning that the whole graph has been shifted to the right 1 unit. So by putting this minus 1 inside of our radical symbol here, that means that the graph is being moved to the right 1 unit. So again, just as with our other parent functions, if you add an h value on the inside, that moves the graph to the left. If you subtract a value on the inside, that moves our graph to the right. And finally, looking at our last activity here, activity C, this is when we are changing our A value, which is our number out front. So let's see what happens if we put a negative sign, a 2, or a 1/2 as our A value. So taking a look at our graphs here, again, we start always with our original parent function, our f of x right here. Then we notice here that for g of x, which starts with that negative sign, that graph is down here. This graph has been reflected below the x-axis. So what this negative sign does is that it flips the graph upside down. Looking at our h of x function, that's this graph up top here, so you'll notice it still kind of has that same shape as f of x. It's just a little bit more stretched. It's almost like taller. It grows a little bit quicker. So the effect that putting this 2 out front had is that the graph has been vertically stretched. Almost like I put my fingers on the top and bottom of the graph and I stretched it up and down along the y-axis. And finally, for our j of x, that's this one down here. Now, j of x, again, you'll notice it still has that shape, but this one rises a little bit more slowly. It's not quite as steep. So the effect that this 1/2 has out front is that the graph has been vertically compressed. It's almost like I took my fingers and I kind of smushed the graph to make it not grow as much. So we see here that the A value can do one of 3 things. It can flip the graph upside down, it can stretch the graph, or it can compress it. So we'll see again that those results, just like all of our other function families, are summarized at the top of page 6. So this is our square root family. We see that the parent function is y equals the square root of x, or more detailed could be written as y equals a, the square root of x minus h plus or minus k. Our original square root graph looks as in this picture. The domain are all x values greater than or equal to 0. The y values are all y values greater than or equal to 0. And again, we see that our function can be transformed in 3 different ways. Our k value on the end, if it's positive, shifts our graph up. Negative shifts the graph down. Our h value, our number inside of the square root symbol, if it's negative, shifts the graph to the right. Positive shifts the graph to the left. And our a value can do one of 3 things. If it's negative, the graph would be upside down or reflected across the x-axis. If it's a number greater than 1, that means our graph has been stretched out. It rises a bit more quickly. And if it's a number between 0 and 1, meaning like a small decimal or fraction, that means that our graph has been vertically compressed, so it does not rise as steeply. So let's take a look at our guided practice here. Again, we're going to compare our k of x function to our parent function. In this k of x function here, we see that our a value out front is 0.3. We see inside of the square root symbol, our h value is positive 3. And we see down here, our k value is negative 4. So the effect that these transformations have, if we start with our a value, we know that if our a value is a decimal number between 0 and 1, that means that our graph has been vertically compressed. If you were to graph this, it would not rise as quickly, it would rise a bit more slowly. If we look at our h value inside of the square root symbol, we see that because we have a plus 3, that means that our graph will be shifted to the left 3 units. And finally, because we have a k value here of negative 4, a minus 4 on the end, that shifts our entire graph down 4 units. So there's 3 different transformations that have been made to our parent function. Our last question here says, how is the starting point of k of x related to the starting point of f of x? So the starting point of f of x, our original parent function, we said always starts at 0, 0. Now, if you were to graph this k of x function, that graph would start at negative 3, negative 4. So how has this starting point been transformed? We would say that the point has been moved to the left 3 units and down 4 units. Okay, so to check how well we understand, let's take a look at our checkpoint question. Please try to pause your video and answer. They want to know, how has this graph been transformed from the parent square root function, which would be just the square root of x. So take a moment to try to identify all of those transformations and then come back to check your work. Okay, so for this checkpoint question, you should have identified 4 different transformations. The first is that the square root graph would be upside down, or you could say that it's been reflected across the x-axis. Again, that's because we see this negative sign out front here. And because we have this 3, that also does some other transformation, which is that the graph has been vertically stretched. You would see your graph rising a bit more quickly. Looking at this -1 inside of our square root symbol, we would say that this moves the graph to the right 1 unit. And finally, for our last number at the end here, this -2 as our k value, that means that our graph would be shifted down 2 units. So for this checkpoint, you should have identified 4 different transformations that have been made. So for your independent practice, if you were not able to get any of those transformations or only one, please start with red. If you are able to identify 2 or 3 of the transformations, but not all, please start with yellow. And if you got all 4 of those transformations, please start with green. No matter what group you're in, please notice that you can now do 2 more questions in your Regents packet, number 6 and number 16. So go ahead and take a moment, pause this video and try those questions, and then come back to check your work. Okay, so taking a look at our answers, here's number 1 on page 6. Here are numbers 2 and 3 on page 7. Here are numbers 4 and 5, also on page 7. So at this point, if you have any questions about this lesson, please let us know. Hopefully you're starting to see the connection among all of the 5 different types of functions that we're summarizing and reviewing in this unit. To wrap up this lesson, please go over to exit ticket 9.2 and answer question number 2. You now should be done with this exit ticket and ready to turn it in. Also, now you should be able to answer numbers 3 and number 4 on your homework 9.2, and that should be done as well.